right, in this video, we are going to look at this problem on page 11 of the Chapter 3, Section 2 slides. Acrosonic manufactures its Brentwood loudspeaker systems in two separate locations, Plant 1 and Plant 2. The output at Plant 1 is at most 400 per month, whereas the output at Plant 2 is at most 600 per month. These loudspeaker systems are shipped to 3 warehouses that serve as distribution centers for the company. For the warehouses to meet their orders, the minimum monthly requirements of warehouses A, B, and C are 200, 300, and 400 systems, respectively. Shipping costs from Plant 1 to warehouses A, B, and C are $20, $8, and $10 per loudspeaker system, respectively, and shipping costs from Plant 2 to each of these warehouses are $12, $22, and $18, respectively. What should the shipping schedule be if Acrosonic wishes to meet the requirements of the distribution centers and at the same time keep its shipping costs to a minimum? So go over to the notepad and we'll take a look at this one. So the respective shipping costs in dollars per loudspeaker system may be calculated as in this table. We've got $20 from Plant 1 to A, $8 from Plant 1 to B, and $10 from Plant 1 to C, and $12 from Plant 2 to A, $22 from Plant 2 to B, and $18 from Plant 2 to C. The number shipped from a plant to a warehouse leads to this table. Maximum production will also be here. This is the maximum that each plant can produce there. So here is Plant 1. We have X1 for A, X2 for B, and X3 for C. And the maximum production is 400. For Plant 2, not 3, but 2. And I lose the pen. For Plant 2, we've got Y1, Y2, Y3. No, the book says X4, X5, X6, so I'm going to go with that. And their maximum production at Plant 2 is 600. And further, we know that we need a total of 200 at warehouse A, 300 at warehouse B, and 400 at warehouse C. From these two tables, we see the cost of shipping X1 loudspeaker systems from Plant 1 to A is $20 times X1. The cost of shipping X2 loudspeaker systems from Plant 1 to warehouse B is $8 times X2, and so on. Thus, the total monthly shipping cost is going to be this. C equals 20x1 plus 8x2 plus 10x3 plus 12x4 plus 22x5 plus 18x6. The production constraints on plants 1 and 2 lead to these inequalities. X1 plus X2 plus X3 has to be less than or equal to 400. And X1 plus X2, X4 x4 plus x5 plus x6 is less than or equal to 600. The minimum requirements of each of the three warehouses lead to these inequalities. x1 plus x4 has to be greater than or equal to 200. x2 plus x5 is greater than or equal to 300. And x3 plus x6 is greater than or equal to 400. So we summarize the linear programming problem this way. Minimize. C equals 20x1 plus 8x2 plus 10x3 plus 12x4 plus 22x5 plus 18x6. Subject to x1 plus x2 plus x3 is less than or equal to 400. x4 plus x5 plus x6 is less than or equal to 600. x1 plus x4 is greater than or equal to 200. x2 plus x5 is greater than or equal to 300. x3 plus x6 is greater than or equal to 400. And x1, x2, x3, x4, x5, and x6 are all greater than or equal to 0. And again, we will look at this problem. We're going to look at this problem in a future section, but we're not going to come back to this one until we get to chapter 4. If you have any questions, as always, get in touch.